we're going to talk, as we said before, we'll talk about the inverse matrices. But before we start with inverse matrices, we're going to talk first about the elementary row operations. So, elementary row operations, or as we can call this ERO, what they are the elementary rows, which the operations which we use to acquire or to find the reduced row echelon form. So we remember when we solve the system of linear equations, we get the initial matrix and we try to remove the redundancy, or we try to make clear what is the most fundamental information by producing as much zeros as possible in the matrix that we find. We do it by using elementary row operations. What are these elementary row operations? The first one is the following. We just interchange a row I with a row J. Okay?
Professor, I can't see from there.
You cannot see it?
No.
Can the others see? Can anyone see?
No.
Yes,
No.
we can.
Yeah.
Can you write a bit down?
Okay, that's okay.
Okay, better.
Perfect.
I wonder if you really didn't see it, because I see the monitor here. I can see the...
It's
I can see it.
It's fine.
It's fine. Okay, we can fix this, of course. So the elementary row operations that we can use to obtain the reduced row echelon form, there are these three. We can interchange two rows. We can multiply one row with a constant, or we can say that rho j star is equal to rho j minus lambda rho I. Okay, so these are the elementary row operations. Now we can represent. So this is an operation, right? This one. Now the thing is that can we represent this linear transformation using a matrix? Okay, that's the first question. What we mean with this is the following. We have reported that any function, we can describe it with the matrix. So can we do this? This is the first question that we're going to tackle. When I say can we do this, is the following. So let's look at this matrix, which is the 1, minus 1, 3, 2, minus 2, 5, 1, minus 1, 2. Okay, so here we have one matrix. And let's assume that we want to make this 0. Okay, how can we make this element 0 using this pivot element 1? If we say rho 2 star is equal to rho 2, then what? Can you help me here?
Minus 2 row 1?
Yes, minus 2 row 1, that's good. So this is an elementary row operation. But now we want to write these types of operations in a way similar to this. Let's assume we have one variable x, okay? Then we have another function g, and we can define g of x. Then, after we apply this operator on x, we want to apply another operator f, okay? And what we get f of g of x, or we can even write like folk gof. Then, this whole system, we can apply another function h, and here we can get here this h of f of g of x. So we want to write all of these functions as a function that is operating on a matrix. Okay, how can we do it? We can multiply in the linear algebra notation. We can multiply this matrix with another matrix, but how? Let's say all of these three operators here, they can be described. So we can try to describe these using elementary matrices. Okay. What is an elementary matrix? Let's see what it is. An elementary matrix is one that we can obtain using any one of these operations from an identity matrix. An identity matrix 3 by 3 is like this one. So this is 3 by 3. And let's say we want to obtain this linear operator matrix. We have here row 2 star is equal to row 2 minus 2 row 1. So let's do this one on this matrix. The first row is 1, 0, 0. Okay. The second row, who can help me here? So row 2 minus 2 row 1. This is I.
Minus 2,
Yes.
1, 0.
What about here?
0, 0, 1.
Okay.
0, 1.
So here, this is EM. Let's call this one elementary matrix. An elementary matrix is a matrix that we can obtain from an identity matrix using a finite number of linear operations, okay, or elementary row operations. So that's good. We found this matrix. Let's keep this in mind. And now let's apply this operator on this matrix. What do we get? So we have here 1, minus 1, 3. And here we have row 2 minus 2, row 1. What do we get here?
0, 0, minus 1.
0, let's see, minus 2, plus 2, yes. Is it 0? I think it is 0.
0, 0.
What about here?
Minus 1.
Minus 1, okay. What about here?
1, minus 1, 2.
Okay, that's good. Then, okay, so we found this matrix. Now, let's try to apply this elementary matrix on the original one, which this is defined as multiplying two matrices. This is 1, 1, 0. Sorry, 1, 0, 0. Minus 2, 1, 0. Minus 2, 1, 0. 0, 0, 1. Okay? So what do we get if we multiply these two matrices? This is equal to this 1, 0, 0. So this 1, 0, 0 multiplying the first row here. We multiply with the first column. What do we get? It's 1, minus 1, 3. Then here we have minus 2 times 1. So we multiply this row with the first column. We get minus 2 plus 2, 0. I think we get here a 0. Correct me if this is wrong. And then we get minus 2 times minus 1. This is 2 minus 2, 0. Okay, we get another 0, it looks like. And then we have minus 6 plus 5 is minus 1. And then here we have 0, 0, 1 times these. It's 1 minus 1, 2. 1 minus 1, 2. Okay? Now, if we compare this matrix with this matrix, they are the same, right? So, so whatever we do with this elementary row operation, which is described here, we have done by using this matrix. How is this matrix? So how can we describe that elementary matrix over there, EM? That one we can obtain simply by applying the same row operation on the identity matrix. So that's how we do it. Now, for a moment, let's see. We did this elementary row operation, but what if we do the following? What if we write row 2 star is equal to row 2 plus 2 row 1. So we have this other one. So let's see what we are going to get. But now we are applying this other elementary row operation, not this. And here we're going to get 1, 0, 0. And here we get 0 plus 2. Okay. This is 1 plus 2 times 0, this is 1. Here we get a 0. Then the last row, it is the same. Okay, let this one be elementary matrix 1, and let this be elementary matrix 2.
Professor, I didn't understand how you multiplied in the first one.
You mean in this one?
No, on the left.
Oh, the left, on my left, here.
Yes. Yes. How you might multiply those two matrices?
These two, okay, thank you for the intervention. So let's see, how do we multiply? In order to, initially, we multiply the first row, but which part we did not pick up?
The multiplication.
Okay, so in order to do the multiplication, we multiply, let me take this out. We multiply, let me take this out too, because this might be confusing. Okay, this is -1. So we multiply the first row with the first column. What do you get? Can you do it for me?
Yes.
So okay, so what can you read it for me? So this is the first row multiplied by the first column. We get 1 times 1, that's 1. Plus 0 times 2 is 0. 0 times 1 is 0. So we get 1, right?
Oh, now I understand it.
Okay, that's good.
Thank you.
You are welcome. So maybe we can try to see what is this. Let's see this one. Let's multiply the second row with the third column. Okay, so let's multiply this with this. So what do we get in that case? Since we have the second row and the third column, most probably the answer is going to be this element. Okay, because this is second row, third column, and this we get -2 times 3 is -6, plus 5 and 0 we get -1. Is it clear?
Yes.
Okay, so you can go over this one even after the class, okay, once you see the notes, your lecture notes that you are writing. So we get this, okay. So here we have one elementary operation, this is the second. This one, this matrix here, which we call this one EM1, or if you allow me, we can call this E1, elementary matrix E1, not EM1. So let's write this E1, let this be E2. E1 and E2. Okay, so let's see we can check. Let's do actually multiplication. Wait a second. Or, wait a second, let's multiply this one with E2. What is E2? 1, 0, 0, 1, 0, 0, 2, 1, 0, 0, 0, 1. And this is equal to, I hope we can do a good job when we do this. So we multiply the first row with the first column. Since these are 0, the bottom elements will have no effect. So here, now we may need to use this space wisely. And also, I think we made this argument here with the function of, so here we have 1, -1, 3. And this is, we multiply the
Second row,
with the
it will be 2 minus 2, 4. No, 5. 2 minus 2, 5.
2 minus 2. No, wait a second. Yeah, I think this is 2 minus 2, and the rest is what? 6 minus 1,
2
5.
minus 2, 5.
5, thanks. Okay, what about the last one?
The same.
1 minus 1, 2. Okay, so what is this matrix? This matrix here, this is equal to this, where we started, okay? So if we call this initial matrix as matrix A, so this is the matrix A, it looks like, what did we have initially? So let's use this part of the board to understand something. So we had, and we call this one E1, right? Elementary matrix E1. We started with E1, we did this. We said E1 times A, this was equal to, let's call this matrix B, which is this one. Then we multiplied with E2, because this is E2. Then we multiplied E2 with B. What did we get?
A.
We got A again. We got this. So let's not forget this is B, and this answer here, this is A, and we denote this one as B. So here we have E2 times B. Let's substitute the B with E1A, right? E1A, and this is equal to A. So this is what we observe. And we know one thing, that when we have a series of matrices that we multiply them one by one, we can multiply them whichever way we want. We can multiply the first two and then with the third, or the second and the third and then one. And in principle, I mean this: A times B times C, this is A times BC. This is something that which is valid for matrices. So here, we can write the following. We can say E2 times E1 times A, this is equal to A. Okay, so this means that elementary matrix E2 times elementary matrix E1 times A, this is A. If this is one matrix times A is equal to A, what should be this product?
Identity.
Thank you. This is true. This would be the identity matrix times A. This would be equal to A. So it looks like these two elementary matrices, they are inverses of each other. So inverse matrix, we denote something. So in this case, we can say E2 inverse, this is equal to E1. Okay? So this means that whatever E1 matrix is doing is being undone by the next matrix. So that's why they are inverses. Okay? So similarly, we can also get the following. We can even write this one. E1 times E2 times A.
We can't read down there.
We cannot read this part? Okay, I'll make better use of the board. Okay. I believe, do you see it now?
No, it's good.
Is there anyone in the class who can see it?
I can see it.
Okay, could it be that you're not watching full screen or something? It's not that I cannot use it.
I said now it's good.
Okay, thanks. Because I just want to make sure. If you want, I can use it in a small area, but try to keep as much things as to make it visible. And try to use this in an ergonomic way. Okay, so from here, we just observe that we can define elementary matrices which can be directly derived by using simple operations from an identity matrix, okay? And it could be also expected by you. There is a little bit of intuition in there. And from here, we also can implement these operations to find the inverse matrix. Let's see an example. So these were elementary row operations. Let's move to another.
Can I ask a question?
Yes.
Where you have written the three steps, step 1, we exchange Ri with Rj. Step
Yes.
what's that CRI? What does it mean?
Which one? The first, second, or the third?
The second row.
The second row, this means multiplying a row with a constant number.
Okay, thank you.
So we can do it a lot, or we have to do it, especially when we want to get a leading one in a pivot row, okay? So that's what it is. Okay, so let's assume we have a matrix that looks like this. 1, 2, 4, 1, 2, 6, minus 1, 0, 1. Okay, so let's assume that we have a matrix A, and we want to apply some elementary row operations and we want to get in the end the identity matrix. Okay. Let me check just one final thing. Excuse me. Okay. So assume that we are starting from a matrix A, okay, and we are multiplying with an elementary matrix E1. This means this is equivalent to changing something about how the rows are dependent, and also the columns. Then we make another elementary row operation, E2. We modify it further. Then another E3, and so on. And let's see if it's ever possible to obtain an identity matrix. So we can modify A as much as possible and try to get this R. But if we apply some elementary row operations like this, and we multiply with A, and we get the identity matrix, what would this be equal to?
The inverse of
The
A.
inverse.
That's correct, okay? So there is an option, we have an opportunity. We could, let's say it this way, we could calculate the inverse of A as a product of elementary row operations. So imagine for a moment, you need to do some changes in a vector or in another matrix, and you do it through these, and then in the end, you might go back and say, okay, what was my initial input? It was a matrix A. What is the final output? Or the result is the identity matrix I. Then you gather all of these and you define a new function. Let's say it this way. You have a variable x, you apply f of x, then you apply g of f of x, then h of f of x. This whole thing, you can call this one as an hx. Okay, so the function h, this can be equal to, what is this? This can be equal to h of g of f. So this is in principle what we are trying to do. And let's try to make this here. And to do this, we try to, let's say, we start with the matrix A, and this is a matrix I. And we are going to do, you remember, when you solve the systems of linear equations, we used to have an augmented matrix. Augmented matrix, it was one where we have the matrix A, and you merge with it the vector B, okay, which is the answer. Now, we merge with the original matrix A, we merge an identity matrix, and then we start the journey of trying to make, to produce from here an identity matrix, which initially should start by producing zeros here. How can we produce zeros here?
Professor,
Yes.
in the identity matrix, why do we have a 1 there in the corner?
Because this is a mistake.
Okay.
Okay. So let's say, but thank you for noting that. So here we have row 2 star is equal to row 2, then what?
Plus row 3.
Well, let's use row 1 as a pivot, okay?
Minus row 1.
That's better. Minus row 1, and then how can you make this 0? We say row 3 star is equal to row 3
Plus row 2.
plus
Row 2.
Well, let's use pivot, okay? If you use row 2, you don't know whether this is going to be 1 after you do this operation, right? Because we're going to do this operation first. And if you are updating, if you are writing a program, you are not using, maybe you are using a single cell to write down the value of this one. So if that value is updated, maybe your equation, you might not give the same result, okay? I think I try to make this clear. But then let's move ahead. The first row does not change. 1, 2, 4. We have 1, 0, 0. And let's see what we get here from subtracting 1 minus 1, 0, 3 minus 2, 1, 6 minus 4, 2. Then 0, 0 minus 1, this is minus 1, 1 minus 0, 1, 0. Then we add, бъдем им гледали, речни пар на речния трет. Потім гледаме, wait. We get here 0, 2, 5, 1, 0, 1. Okay? Then, so this was a pivot element. Okay? Now, this is a pivot element. The issue is, how can we make this 0? How can we make this 0? We can say row 3 star, this is equal to row 3, then what?
Minus row 1.
Minus row 1.
Minus row 1?
Plus row 1.
If you do minus row 1, you are going to change
Minus 2 row 2.
minus 2 row 2, yes. Let's not forget that when we want to get reduced row echelon form, we want to make all of these zeros, okay? So we want to make these zeros, which means that if we make this a 0, we may undo that. So we don't want to do that. So let's follow this second suggestion of yours. So the first row stays the same, 1, 2, 4, 1, 0, 0, and then we have 0, 1, 2, minus 1, 1, 0, and then we follow with a 0. Then here we have 2 minus 2, 0, 5 minus 4, this is 1, 1 plus 2, 3, 0 minus 2, minus 2, 0, this is 1, okay? So we did the first part. So these numbers, we made them 0. The second task, the next task, is to produce zeros from here. Because we want to simplify this as much as possible. So to produce row zeros up here, we should start using the third row as a pivot row, okay? So how can we make this 2, 0? This would be row 2 star, would be equal to row 2, then what?
Minus 2 row 3.
Minus 2 row 3, thanks, okay. Then how can we make this 4, 0? This is...
Minus 4 row 3.
That's correct, minus 4 row 3. So we wrote these equations here, and then we move to the right. This is 0, 0, 1. So this is the pivot rows, and this will not change. 3 minus 2, 1. Then here we say row 2 minus 2 row 3. So this is 0 minus 0, this is the same. This is 1 minus 2 times 0, this is 1. 2 minus 2, this is 0. Then we say here, this is 1. This is 2 minus 2 row 3. I think we did this very fast. So, is this true? 2 minus 2? No.
No, row 1 is row 1 minus 4.
That's correct. This minus, yes, I was confused. That was, so this is minus 2, that's correct. 4 minus 4 here. No, wait a second. That's a mistake.
That's just 2. 2 minus 4 times 0 is 2.
Yeah, you are right. You are right. That was a mistake. So let's follow here. We have here row 2 for this element here. Minus 2 row 2. Minus 1. Minus 6. Minus 7. And then we have 1 plus 4. This is 5. And 0 minus 2 minus 2. Then we follow the same, row 1 minus 4 row 3. This would be row 1, 0 minus
11.
Minus 11, that's true, okay. And then 0 plus 8, we get 8. And 0 minus 4 is minus 4. What is the next step? So this was a pivot element. This is a pivot element. Above and below these ones, we have all zeros, so they are good. The only number which is left to make a 0 is this 2 here. Okay, this is the last element. We need to make it 0. So what?
Row 1 star is equal to row 1 minus 2 row 2.
No, row. Okay, that's true. This is row 1 minus 2 row 2. Row 1 star, this is equal to row 1 minus 2 row 2. So here we get 0, 0, 1, 0, 1, 0. Then we remove twice. This is 1, 0, 0, 0. 3 minus 2, 1. Minus 7, 5, minus 2. And here we do the changes, which is from the first row, we remove twice the second one. So we have minus 11 plus 14, it's 3. 8 minus 10 minus 2. And minus 4 plus 4, 0. Okay, so what do we have here? We started here with this matrix, so I think this is all. But let's not forget that we started with AI, or let me draw it like this.
Now we have IB.
Yes. So we started with AI, and we applied on AI a huge elementary matrix E. And then this was applied in here and in here, so we can write this one as EA and EI. Okay, so then we said, after we applied this elementary row operations, EA, what did EA become?
I.
Yes, so this EA, this is the identity matrix. And this identity matrix, before we write the rest, what do we obtain from here? We see that E times A, this is I. What can we conclude from here? It looks like
E is A minus, inverse of A.
that's right. So this is the only case, so that when we multiply this with A, we get an I. So if this is the case, E, then we can write the rest like this. So where did we get this? We get this from here, right? Then before writing this, we say A inverse, based on this fact, A inverse times I. So what is A inverse times I? What is A inverse times I?
A inverse.
A inverse.
A.
So it looks like this is A inverse. So we could find a matrix or a construct, a mathematical construct, which if we multiply this A inverse with this initial A, we should get an identity matrix. Okay. And this inverse matrix here, this AI or this A inverse, let me write it like this. A inverse is equal to what? What did we do initially? Let's look at these operators. Initially, I think we have to write it from this side. So initially we did this, row 2 minus row 1, okay? How can we denote that? Let's see. Row 2 minus row 1. We have an identity matrix, 1, 0, 1, sorry, 0, 0, 1, 0, 0, 0, 1, right? We start with an identity matrix, we apply this elementary row. What is row 2 minus row 1? I'll try to do this fast, so please correct me if I make a mistake. Row 2 minus row 1, we get here 0 minus 1, this is minus 1, okay. So this is it. This is the first elementary row operation that we conducted. Then, what was next? 1, 0, 0, 0, 1, 0, 0, 0, 1. What is the other elementary row operation that we did, that we started here? It was row 3 plus row 1. What is row 3 plus row 1? It's this one, right? So now, again, if you look carefully, what this really is, this is row 2 minus row 1, right? This one is row 3 plus row 1. Okay, then what did we do here? We said, let's let's write here the other matrix 1 0 0 0 1 0 0 0 1, and let's see how we can denote this elementary row operation into this. What is row 3 minus 2 row 2? Row 3, this stays the same, minus 2 row 2. This is minus 2. This is it. So this is row 3 minus 2 row 2. Row 3 minus 2 row 2. Okay. What was the next operation that we did? This was row 2 minus 2 row 3. So let's keep this here. Row 2 minus 2 row 3. This is 0 0 1. This is 0 1 0. But we need to do row 2 minus 2 row 3. So this is going to be the same with a minus 2 here. I want to ask, can you follow me here?
Yes.
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 Okay, so this is row 2 minus 2 row 3. Then we need to do this row 1 minus 4 row 3. So here we have row 1 minus 4 row 3. This is going to be this one minus 4. We have a minus 4 here. I'm not going to write the expression, what we can do. Row 1 minus 4 row 3. Then after this operation, what was the next one? We did row 1 minus 2 row 2. So this is 1 0 0 0 1 0 0 0 1. So row 1 minus 2 row 2. How should we change this?
1 minus 2 0.
Thank you. Okay. 1 minus 2 0. And this is, let's write this a little better. This is minus 2. And this is also minus 2. It was good, but okay. Now, these are all the operations that we did. Only that we have to notice that if we multiply all of these matrices, what do we get? We get this one, right? Okay, so if we multiply all of this, so apparently we obtain the A inverse by using 5 elementary row operations, because we can count them. We have here, no, maybe 6. 1, 2, 3, 4, 5, 6. Apparently there are 6. How many matrices do we have here? 1, 2, 3, 4, 5, 6. Okay, we have 6. I thought we had less. So we have 6 elementary row operations. We could easily obtain in less than 3 minutes all these 6 matrices. Okay, and we are sure that if we multiply this, we get this. But one thing is that we should be careful. Is that when we apply these row operations, we apply it initially here. Okay, we write it here. Is it clear? Can I get a confirmation?
Yes. Can you lower a bit the camera, please?
Which part you don't see?
The down part.
The bottom part. Okay. Yes. Okay.
There is perfect.
That's perfect. Okay. Okay. So the first elementary operation, we put it to the right. I hope we understand this, because this is equivalent to saying the following. Just a small example. Let's say g of x is equal to x squared, right? F of x, and this is equal to x plus 2. H of x, this is equal to 3x. Okay, let's assume that we have these 3 functions. And then we want to find what is the h, sorry, whatever this is, or h of g of f of x, right? So what do we understand from here? We have to apply first f on x, which is what? X plus 2. So this becomes x plus 2 times h dot g. So if you see, if this is the first operation, we keep this closer to the vector that we are going to modify, okay? So similarly, if we did this elementary row operation, ku do e vendosim A-n te këto shprehje. A-n, që do e gjejmë A inverse her A. A-n besoj të shkruajmë këtu në atë. So here we have 1, 2, 4, 1, 3, 6, minus 1, 0, 1, right? So we are multiplying this matrix first with this. Then this output of this result we multiply with this other matrix. Then the outcome multiplied by this matrix. So similarly, this is how we apply this. And this probably could be written as h. What is g of x plus 2 is x squared. So this is going to be h of x plus 2 all squared. What is h of x plus 2 all squared? X minus plus 2 squared is 3x. So this would be equal to 3 times...
Professor, can you move a bit right?
Yes. Okay, so I hope this is this is clear. And meanwhile, I could, regarding these elementary operations, I could provide a different example, but maybe we can push it a little later. Once, okay.
Can we take a break, please?
Let me think. You'd like to have a break? Okay, we can have a 5 minutes break. And
Can we make it 10?
Can you make it 10? You're pushing
Vi
so
që kemi
hard.
qef dhe më sentoren, prandaj.
Keni qef mësimtoren? Po, që të kesh qef mësimtoren, do të thotë përgjigjesh pyetjeve që do bëj unë për mësimtoren. Si kishte emrin ai trimi, ai komiti?
5 minuta dhe ika.
Jo.
E lëm 5 minutë.
Okay. Sa shpejt do tërhoqet më çon. You should fight for your cause. You should